Good morning, everybody, or good evening, wherever and whenever you are. In this video, I'll be explaining on how you could, well, add two numbers, 8-bit numbers, well, they're binaries, using LogiSim, which is this great software and this great tool we can use to simulate circuits uh, without actually needing to have a circuit, which is really nice. So what we need here is you need these inputs to show like what what number it is. So I can make these zeros or ones. Well, when you have eight of them, you have 8 bits. So I could have 0 1 0 1 0 0 0 or 0 1 0 1 0 0 1. So I could use this to essentially just show bits using numbers. Sorry, using pins. These are called pins in the LogiSim software. And we will need to add these two numbers. Well, a problem you could face when adding numbers is this number might be negative. But how do we display negative using bits? There's no sign here in the computer. So what we will need to do essentially is put this through a ones complement or a twos complement. Well, you'll see that later, but for now we'll put it through a ones complement where we could flip everything, and this would be, and we'd use this last bit as a negative or positive indicator. So if this is 1, it's negative. If this is 0, it's positive. So let's do that. Well, now we have essentially turned this into a ones complement. So if I were to have in here, well, I would be subtracting. So this we would turn this into negative because something plus something that's negative, it's essentially you're subtracting it. So I can subtract number A from B. So I could like it would be B minus A from. I could so let's say it'll, well let's say I have 0 1 0 0 0 0 0 0. If I want to turn this into a negative, I would just press this and it would be 1 0 1 1 1 1 1. Well, we notice that this last bit here is 1, indicating this is a negative. So then if we flip it again, we would get negative 2, which is something that is very nice. Well, what we do need is a splitter for this. So we could just put this all through one neat wire. Because, well, oops. Um, so the splitter, what we could do is we could put 8 wires and we could output it through one as this wire. So what we'll need to do is we need to make this face north for the first of all and have the input as 8 bits and the output as 1 bit through one wire. So if we connect this, now we have a splitter and we have this neat little wire that will carry the bits, will carry 8 bits. So let's say for example I have 2. Well, this can now know that it's 2. Well, if I want to turn it to a ones complement, it knows now it's negative 3. Well, the problem with ones complement is you need to add a 1, which will be a carryover. And this will turn it into negative 2, which is what we need. So let's put it through this neat little tool we can use, which is called an adder. This adder tool is very, very important. And so we could put this in here and this in here. Oops. Like that, and we'll have an output, and we could put a carry 1. Well, I'll connect this in a neater way and explain to you how this works. So here we have connected it in a more neater way, and a good feature of LogiSim is you could always go to help and library reference and open any of these. Essentially, you could read the multiplexer, you could read about the adder with this carryover and everything, and this is a very, very useful way to learn how to use this software. Well, I've connected these, so I'll stop blabbering, and you could use the pointer tool to check what is being sent through this wire. So here we have a negative 3 and here we have a 1. So negative 3 plus 1 will give us negative 2, and we've added this carryover, which is a 1, and this would yield us negative 1. Uh, we could now, well, this is a 1, 1, 1, 1, 1, 1, which is in 2's complement, it's a negative 1. And when you put this through the NOR gate, the NOT gate, it's zeros. And since it's 2's complement, we add 1 because we're flipping it and adding 1, which will give us 1. And this adder, we would want this to yield us unsigned output, which we could use here. So we could put this through a multiplexer, which is which looks like sorry, you have to use this one, which looks like this, and we need to put this multiplexer facing south with 8 bits output and input, so here and here. And we need to signal to this multiplexer which one of these we would like to use, since a multiplexer is essentially kind of like a railroad we could use. So let's do that now. So we could put this through a splitter again, just to show us it in 8 bits. So the splitter's right here. Essentially, actually, let's just copy this one. So it's like this right here. And we will take this last bit and we would choose which one we need. So since here it's 1 and it's negative, because the last bit is 1, we'll take this one instead of this one because it's 0 and 1. If this is a 1, we take this wire. If this is a 0, we take this wire. So we're not going to be taking this wire, we'll be taking this wire. And we will need to output this and to show us the answer. So again, we'll take a splitter. Actually, let's just take this. And we'll place all of these with buttons. Uh, Here, we need to make this, yeah, it's this one right here. Yeah, this is a button. And we need to make this face downwards. So south. And we will need 8 of these, and the power of exponential will let us do this. And here we have 8. And we will need to make all of this face south. Oh, oops. Well, we could just connect this, honestly. And yeah, here we have a 1. So 2 minus 1, or even 1 minus 2, gives us a negative 1, but we want this unsigned, so there should be no 1 here. And this is a 1. We could try many things, so we could have 3 minus 1 gives us 2. This would be 4. This would be 3 minus 5, or 5 minus 3 gives us 2. And we can check this is legit. If we press here, it says 2. Well, now we've achieved everything, and this is how you could build this. This is a 2's complement, this is a power, and this is a ground. So this is just 1. We flipped it using the NOT gate, added 1, and we ended up with minus 2. And here, we've got this 2 here to the 1's complement, and since the last one is 0, so this is unsigned, this will yield us 0, and we take this one, and this will give us 2. So I hope you understood everything. This is, last thing I forgot to add is this is subtract. This will tell us if you press this means you're subtracting. If this is 0, you're not subtracting. So this is essentially everything you need to know about this circuit. And yes.